But yeah, absolutely, use whatever tools make you happy, I'm not tool centric. We'll also probably be using GitHub pretty extensively in this course, because GitHub, please don't confuse Git and GitHub, they're two different things, but GitHub provides some pretty decent interfaces and stuff to do some of your Git work. So anyway, there's a Git directory here, and I do require in this class that when you're doing some work like I just did, we should probably log that work somehow. I'm going to say git add. First of all, I'm going to add to git ignore this, because I really don't want to check in the cargo.log. And then I'm going to say git add dot git commit -m example program in Rust. So, whoops. Oh, right, I forgot to set up my Git stuff, because this is a new throwaway account. Oops. Oh, what am I? I'm in Nano. Oh my gosh. No, no! Control X. No, don't save anything.
What did you add to your .gitignore file?
I added cargo.lock so that it doesn't check in my lock file. I don't want my lock file checked in. Welcome to the world of Unix. Okay, let's try this again. There. Man, I got Nano. I can't believe it. There. So let's see what my log says. It says something perfectly reasonable. I've got a log message now. What files are in my commits? Oh, nice. It checked in my .gitignore and .gitignore tilde. How nice. Oh, forget it. I just do the dumb thing. Okay, now I got myself a nice, lovely Git repository that I could push up to GitHub if I wanted to. It all is right with the world, and that is building and getting running a Rust project. That's the first part of your first homework, is to actually do that. Except instead, oh, by the way, I was pointed out to me at the break that the actual first couple of instructions for the first homework I got kind of wrong, because it's that kind of a day. I didn't realize the restriction. I actually did the whole homework already, except that first couple steps, because I know how those go. You're so close to it. So I'll fix it up a little after class so that it's clearer. But the basic idea is you're going to clone a repository in our repository space that has a Rust program all set up to go, but partially filled in. And partially filled in, and you're going to finish filling in with some stuff. So I'll talk about that soon. Yeah.
Is there going to be like, are you going to send out like a guide kind of how to get set up on this? I was trying to follow, but got a little lost.
Well, I mean, the notes for today have stuff in them. I'm not sure what more I can really send up. The book itself has a bunch of a whole chapter about cargo that's part of this month's reading, of this week's reading. There's good tutorials for all this stuff online.
The notes were in an email or BTO?
They're on the Moodle. They're on the course Moodle, which is this thing I was pointing at earlier. And like I say, I'll get everybody enrolled in that Moodle in a couple days, and then it'll be more obvious where it is, but for now, it's... And I'm not using D2L, because I've had it with D2L. It's caused me too much grief, and I never want to speak to it again. This is the address of the Moodle. You can go to there and then click on the course. and that'll take you to the, where the notes are. And the notes have some walkthrough. The homework assignment itself has some detailed walkthrough. So, yep. Yep. And like I say, you know, the book has a lot of things, and there's a lot of things available online. I would encourage everybody to be pretty aggressive about using Google, you know, in this course, because it's very unlikely that there's any questions out there that you're likely to have in the first few weeks that a million other people haven't had. It's very likely that questions to all those, answers to all those questions are on the internet. Also, once we get the Slack channel set up, you can always ping me, #help on the Slack. Yeah. I mean, it's set up now, I just don't have any good way to give you the link until you can Google it. I don't want to give the link to the world for small reasons. Yeah, that. So right, so now you've got a project, it's all checked into Git, you can push it back up to GitHub if you wanted to. Let's quit doing this for a minute, because I don't really want to work with this throwaway account. I just wanted to go through the basics of what's going on, but I don't really care about this dumb throwaway account, so I'm just going to leave it and go back to my own account, so I know what's going on. Everything's set up nicely. Oh yeah, I was in here. Sorry about that. Actually, I don't even want to do that. Let's actually show you something different. Let's show you play.rustlang.org. This is the Rust playground. It's one of the cool things Rust has to offer. So maybe you don't want to go to all the trouble of messing with cargo and setting up a giant cargo project. One good way to deal with that would be to do this, which is to go to play.rustlang.org, and you can actually type code in here on the web. This is just a website. And then you can compile and run that code. It's perfectly happy to do that for you. And if I can scroll here, which is always a trick, yep, sure enough, that worked. This share link over here is fantastic. This one that says permalink to the playground. I've now got on my clipboard a link to this particular play.rust thing. It's stored as a GitHub gist. And so if you're asking for help with something, and it can be formulated as a small program that fits naturally in the playground, a good thing to do is to go build something in the playground and send me the link, and then I can play with your code and understand what's going on. Please don't send me screenshots of code. It's really super frustrating. Find some way to send me code as text so that I can mess with it instead of trying to figure out. My vision's bad for one thing, and so I probably want to be able to read your screenshot. So let's play with the playground for a little while and see if we can understand some things about this goofy programming language real fast. And then I'm going to go through the assignment a little bit, and we're going to be out of time. Let's print a number. That sounds like a thing. If I run this, I'm going to guess it'll print 5. Let's split this the other way. Maybe that's what how you get to split vertically. Might need some good options. Orientation, vertical. That vertical? So it's given us a 5 there, just like you'd expect. Those curly braces are the equivalent of C's printf % operator. They say put the value, the next value from the list in at that spot. You'll notice then, like C's operators, you don't actually have to specify what kind of thing to print. That's because Rust knows what type the thing is, because it's a typed language, unlike C, whose printf is just like, I don't know, passed me a thing. It might be an address, it might be a data. Please tell me what it is so that I can figure out what to do. This one's like, nah, I got this. I know what you're printing. So I can print numbers. I can print floating point numbers equally well. I can print strings. So this works just like you'd expect it to. Yay, output. Input in Rust is a lot more of a pain in the neck, but output's really quite easy. And it looks, like I say, a lot like the C stuff. Basically, any type that implements display, which is all the standard basic types, pretty much. Yeah, all the basic types, can be printed. It's perfectly happy to do that. We obviously can have expressions. That's a thing. So there's the sign of 3. That's a weird number. Except it's like, I don't know what to do with that. No sign, no for generic float. That's a terrible error message. It's worse than most error messages. In general, when you get an error message in Rust, it's pretty clear about what's going on, and tries to tell you what to do. In this case, I happen to know that probably a better way to write this is 3.0 f64.sign. It just doesn't know whether I want a 32-bit or 64-bit floating point number. If I tell it, no, I want a 64-bit floating point number by sticking the type suffix on the end, it's perfectly happy. That's a weird way to write the sign function, though. It's very object-oriented looking. I don't like it. It's gross. I'm not going to do that. I refuse. So instead, I'm going to write this. That will also work. And print the same answer, but I find it easier to read. Notice a thing that's going on here, right? This thing is actually type checking, even though we never declared any types anyplace. So let's add, instead of adding a number, let's add a string to this. And it will actually fail. It's like, no, you can't add a number to a string. Well, that's not too surprising, but we'll see a more surprising thing in a second. And what we're going to do is learn how to declare variables. We'll do it like this. Okay. And now I get, binary operation plus can't be applied to sign. Oh, sign is also not found in this scope because I didn't tell it which sign I meant. I could do what I did before and put F64 colon. Another way to do that would be to use the module system. You'll read about that this week. There, now I've used the sign operator for F64s. Standard F64 sign, yeah. Okay. So I know how to write Rust, honest. Everything's wrong today. Okay. Try it again. That's really weird. I don't understand it. path exists, standard colon F64. Okay. I'm just gonna go back to doing it the dumb way. I don't wanna think about this right now. Apparently I don't know how to program in Rust anymore. But what I was trying to get at, 3 dumb mistakes ago, that I don't even understand, is look, I can't program in Rust. Honestly, the pattern you're seeing here, which is the compiler just going, no, I don't like your thing, you'll see that pattern a lot. That's the compiler saying, I don't know what you're doing, so I'm going to say no. The compiler's very, very unforgiving. You know, the C compiler loves to give you warnings, or just silently take stuff. It's like, I don't quite know what's going on here, so I'll make my best guess and go on. C++ is very happy about that. Or I'll whine at you a little bit. No, you should probably fix that. I don't think it's what you meant, and then it goes on. The rest of the compiler's like, no, we'll be stopping now. I don't know what you mean. Anyway, this should fail. But the interesting thing is it fails, right? Even though we haven't really declared the type of either of these variables. We could declare the type of them, we don't have to. What happens, and is this a runtime failure? No, it's a compile time failure. Let's try to build instead of running. And what you'll see is that this is a compile time failure. It fails during the build phase. That's pretty cool. That's called type inference. It tries to figure out what type everything is from how it's used and at compile time. And if it can't figure it out, it just refuses. So most of the time inside functions, you don't actually have to declare the type of anything. It just goes, oh, I can figure this out. If I can't figure it out, guess what I'll do? You know, and so that's pretty cool. And so you get all the safety of the statically typed language without having to type nearly so many static types. You'll also notice that the let syntax here is being used to create new local variables. That's pretty standard stuff. Nothing too surprising there, I think. Let's try this. All this garbage over here. So here's a lovely adding one to a variable kind of thing. It's like, I don't think so. I can't. The first assignment to I is this let here. Help, make this binding mutable. It's like, say mute I because you can't assign twice to an immutable variable. See, that's a pretty clear error message right there. It's like, why didn't you type this? It turns out to be able to change the variable, you actually have to explicitly declare that it's a mutable variable. Yeah, now it's just in build mode. We really want it to be in run mode again here. So let's make sure it runs and does the right thing. And the playground's being slow. Nope, there it goes. So there you go. Now I can mutate that variable because I said it was mutable. That's an interesting thing. Mutability is kind of bound up with the notion of ownership, which we won't talk about until like week 3 because we've got so much to talk about. But the idea is that if, you know, by default things you aren't supposed to change things unless you say you're gonna. And there again, that's just a safety thing to make sure that you know what you're doing. So when you do the obvious other hello world, the first thing you write after you write hello world typically is you write this. Right, we count to 10 because that's one of the things that you do when you're learning a programming language is count to 10. And you'll notice that I'm putting brackets in here. It turns out those brackets are not optional. They're mandatory brackets. You have to bracket all your control statements. You'll also notice that the syntax doesn't look like quite what you're used to. That's because that thing there is on the right-hand side of in is actually a whole bunch of deep magic, but for now, we'll just treat it as the lower and upper limit of the iteration. It's just like C, it starts at 0, it ends before 10, so it goes 0, 1, 2, 3, 4, up to 9. So we're counting to 10 as computer scientists. If we want to count to 10 as normal human beings, right, there's a lot of choices here. The obvious one is to put a +1 here. And now we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay! We actually know how to do this. So that's control flow pretty much. That's the for loop. There's also while loops. You know, we can do those. There's if tests and all the obvious stuff. One interesting thing about Rust, well anyway, we've only got a few minutes left. I'm gonna switch away from the playground here. But you get the idea. It's pretty much a programming language for as far as first day is concerned. It has numeric types. It has string types. The string types are weird to work with. We'll talk more about them on Wednesday because they're not super obvious. And then we'll talk way more about them later in the course. We'll be talking about string types all quarter. But trust me, it has string types. They're perfectly reasonable. Well, I guess the other thing I should say is it also has perfectly reasonable arrays. Let's do this. So this is called a vector. I'm going to make it a mutable vector because I want to be able to change it. By default, it starts empty, so I can say this. And now, on each iteration of the loop, it will push that number onto the end of the vector. So the vector will grow now to have 10 things in it, 0 through 9 or whatever. And now, if I println the fifth element, it should be 5. And this works just like you think it will. It's mutable, so its contents are mutable. Mutability is a deep concept, so I can do that. And then I can println it again with terrible copy-paste coding that no one should ever do. I'm going to copy and paste this.